Section 5.7 is on interpreting graphs of linear functions. So linear functions have a lot of implications in the real world, such as business and sciences, and it's important that we be able to examine linear functions and understand their implications. So before we begin, we're going to define a couple of terms. The horizontal intercept is the place where the graph crosses the horizontal axis, and it's often called the x-intercept because usually the horizontal axis is the x-axis. A lot of times, though, could be labeled something different, like if the x-axis was representing time, it might be the t-intercept. The vertical intercept, then, similarly, is the place where the graph crosses the vertical axis, or your y-intercept, it's often called, again, just because the y-axis, the vertical axis is often labeled the y-axis, but again, that could be something different as well, depending on what the dependent variable is used. So the horizontal intercept, if we write those definitions down, is the point where a graph crosses it's not a very good E, crosses the horizontal axis. And I'm just going to put X there in brackets because that's the most common name for the horizontal axis. And the vertical intercept is the point where the graph crosses the vertical or y axis. And when you say the point, you can give that point as an ordered pair, listed as an ordered pair, or sometimes they'll just use the variable defining that axis. For example, if it's the horizontal intercept or x-axis, they will just say x equals whatever value it is, or they could write it as an ordered pair, and we'll just do some, I'll show you that when we get into the examples. So the first graph is about showing the rate at which water is draining from a bathtub. So the first question is to examine where the graph intersects the v and g axis at points A and B respectively. So in this case, the y-axis is labeled actually v for volume, and the x-axis is labeled t for time. And when we're asked to explain what's happening at A and B, A is the vertical intercept. So in terms of what's happening there, the best thing to do is just kind of look at the coordinates for A. A has coordinates of 0 for the t coordinate and 80 for the v coordinate. So at time, what that means is that time equals 0 minutes. The tub has 80 liters of water in it. So basically, when they first started looking at this, the tub was full and it had 80 liters of water in it. Explain what's happening at the B, or the horizontal intercept. The B coordinates, we look at the coordinates, they're 16 for the time and 0 for the volume. So what that basically means is that it took 16 minutes for the tub to reach a volume of 0 liters. So basically 16 minutes for the tub to drain. So this means it took 16 minutes for the tub to drain, or the water to drain out of the tub. Probably would be better to say. Okay, so if we summarize this information now that we just found, we have the horizontal intercept is, you can say, two ways you can say it. You can say t equals 16, or as coordinates, you can write it as 16. 0. And the vertical intercept, you can write it as V equals 80, or as an ordered pair it would be 0, comma 80. The domain for this relation is describing the times that can be used. So this particular graph, the times are from 0 would be the lowest time that's used, up to 16 minutes is when the tub finished draining. So it would be everything in between 0 and 16. Now that's just using an inequality. There's several ways you can write that though. You could use set notation, or you could use interval notation. If you used interval notation, just to practice that, you could say that t belongs to 0, comma 16. And the range would be basically the volumes of the tub go from 80 liters down to 0 liters. So again, you could write it as an inequality. So it doesn't specify what way to write the range. And you'd use volume, so from 0 down to 80. And again, if you wanted to write that in interval notation, just to practice our interval notation, would be, lowest would be 0, highest, or the right endpoint would be 80, and it would be everything in between. And the rate of change there, we have to go back to the graph again and look, so we can pick two nice points on the graph. And you can basically take the intercepts if you want and realize that basically you have changed. You've gone, basically the change in volume has been 80 liters, and the change in time has been 16 minutes. But the volume is decreasing as time goes on, so that would mean you'd have to make sure that you have a negative rate of change. So that would be negative 80 over 16 liters per minute, or negative 5 liters per minute. And that's just means that the tub is losing 5 liters of water per minute. So by using the word losing, that kind of replaces the negative symbol. So losing 5 liters per minute. Okay, this first example to try is a scuba diver's depth is recorded during a recent dive. The graph shows his diving depth in meters in relation to time in minutes. So again, you have to explain what's happening at A, the vertical intercept. So if you look at the coordinates of A has 0 for the time coordinate, and for the depth coordinate, it is negative 12. So if you had to interpret that, you would basically say that at the start, the diver is 12 meters below the surface. So at time equals 0 minutes, the diver is negative 12 would be 12 meters below the surface. And the B intercept, if you look at the coordinates of B is 30 for the time and 0 for the depth. So that would mean that it took 30 minutes for the diver to reach the surface of the water. So if we summarize those bits of information there now in terms of the charts here, we have the horizontal intercept would be, in this case, t again for time is 30. And as a coordinates, that would be 30, 0. And the vertical intercept is D, I believe they use. I'll just go back and see D for depth, yes. So D equals -12, or as an ordered pair would be 0, -12. And the domain, again, would be from times from, we'll just use interval notation just to practice that, because this is continuous data. So the times would be, the lowest time would be 0. So time belongs to, lowest time would be 0, which is included. And the highest time is 30, stops at 30 minutes, and that would be included. And the range would be, the depth, we use interval notation, would be from, the lowest depth is -12, and that's included as a start point. And the highest depth would be 0, or you're back to the surface, and that's reached as well. And the rate of change, again, you can just basically figure out the change, the dependent variable. There's a change of 12 meters there. And you can use any 2 points. I'm just using the intercepts, but you can use any 2 nice points on the graph to find the rate of change. It's just that you probably won't have to reduce as much if you use points that are closer together when you figure out the rate of change. So the time frame in that that depth was reached was 30 minutes. And if we look at the the depth is increasing as time goes on. So this would be a positive rate of change. So we would be expecting a positive answer. So this would be 12 meters over 30 minutes. And you usually don't talk about, when you're talking about depths and distance and things like that changing, you don't usually talk about that in fraction form. So you just say 12 divided by 30 as a decimal would be 0.4 meters per minute. Now, next example shows the change in height above the ground, h in meters in relation to time t in seconds while on a zip line in Bay Bulls. So the first thing you're asked is determine the vertical and horizontal intercepts and describe what the intersection points, I don't think they mean intersection, I think these intercepts, it should be. That should be intercepts. Okay. So the first one is the horizontal. And that would be t equals 22. Or 22, 0. So that means that it took 22 minutes to reach a height of 0. So it took 22 minutes to reach the bottom, or height of 0. And the vertical intercept would be height use the lowercase h as it is on the graph there. So the height would equal 55. If you look at the height at this is between 50 and 60, so 55. Or as an ordered pair, you could write that as 0, 55. And that would mean start at the zip line at a height of 55 meters. that in. Okay, state the domain and range of this function. So the domain would be, again, you can just do inequalities or integral notation, whatever you want, or set notation. I'll just use an inequality this time. So the lowest time that's used is 0. The highest time that's used is 22. And you'd have your times in between there. And the range would be the lowest height that's reached is 0. The highest height that's reached is 55. And you would have your h variable in between there, and it can be equal to either of those. So it would be height is greater than or equal to 0, less than or equal to 55. Okay, so when you're graphing a linear function, there's lots of methods you can use. We've already used table of values, but now we're going to try a couple of more methods that you can use, and one of them involves using your horizontal and vertical intercepts. The other one involves using your rate of change and the vertical intercept. So the first one is graphing using the horizontal and vertical intercept. So basically all you would have to do there is first find the horizontal intercept and the vertical intercept, and to graph a line you only need at least 2 points on the line. So the horizontal intercept would be 1 point, the vertical intercept would be another point. So plot those points and then just connect the points to form your graph. The only problem with using this method to graph is suppose the line actually crosses through the origin or the point 0, 0. Then your horizontal intercept would be exactly the same thing as your vertical intercept, and you would only have 1 point, which means you wouldn't be able to graph it. You'd have to, using that method, because you need at least 2 points, so you'd have to actually probably do a table of values and pick another point at least to be able to graph it. But the ones we're going to give you now will have a distinct x and y intercept so that we can practice this method. All right, so if you look on the horizontal axis, you should notice one thing about every single point on the horizontal axis, and that is that the y coordinate of every single point on the horizontal axis, right here, right here, right here, right here, all the way across, the y coordinate is always, always 0. And similarly on the y-axis, every single point on the y-axis has an x-coordinate of 0. So we use that idea to help us figure out the y-intercept and the x-intercept. If we're looking for the y-intercept, we let x equal 0, because every point on the y-axis has an x of 0. And if we're looking for the x-intercept, we let y be 0, because every single point on the x-axis has a y-coordinate of 0. So if we try a few examples now and use that method. So the first one says to sketch the graph of the linear function y equals negative 2x plus 8. So to find the x-intercept, we let y equal 0. So that would be 0 equals negative 2x plus 8. We just take our equation, and instead of y, we're going to fill in 0. So then we're just solving a linear equation. You want to isolate the term containing the variables, so you want to get the negative 2x by itself. So you are going to subtract 8 off both sides. If you subtract it off the right side, you're going to have nothing left but the negative 2x, and then you subtract it off the left side. So you're going to have negative 8 equals negative 2x. And then you want to get the x by itself. So you want to get rid of that negative 2 that's multiplied by x. So to do that, you're going to divide both sides by negative 2. And that's going to give you 4. So our x-intercept is 4, or 4, 0. So if we plot that, we've got 4, 0. So to find the y-intercept, it's where it crosses the y-axis. So the x would have to equal 0. So then we just take our equation, and instead of x, we put in 0. And that gives us 0 plus 8, or 8. As an order pair, that would be 0 for the x, 8 for the y. So then we just plot that point, and then we connect those 2 points in a better line than I've got drawn there, but you got the idea. Okay. So the next example shows you another equation, same idea though. We're looking for the x-intercept. We let y be 0. So the y in this case is the same thing as f of x. Y is the same thing as f of x. So we would be solving 0 equals 3x minus 6. F of x is the function value or the y value. So then you've got to get the 3x by itself, so you would add 6 to both sides of the equation, so that'd be 0 plus 6. And when you add 6 to the right side, the negative 6 and 6 cancel, leaving you with just 3x. So then you've got 3x equals 6, and then you want to divide out the 3 so that you get the x by itself. So x would equal 2. And then to get the y-intercept, we let x be 0. So then that's going to give us f of 0 equals 3 times 0 minus 6, which is going to give us 0 minus 6, which is going to give us negative 6. So that would mean that the y-intercept equals negative 6. So y equals negative 6, you plot that point on the y-axis at negative 6, and x equals 2, and connect. Next example for you to try. X-intercept at y be 0. So you'd have 0 equals negative 2x plus 4. So then 0 minus 4 equals negative 2x. You want to get the x term by itself. So that's negative 4 equals negative 2x. And then you want to get the x by itself, so you're going to get rid of that negative 2 by dividing it out of both sides, which is going to give you 2 equals x. And then the y-intercept, you're going to let x be 0. So then that's going to be f of 0 equals negative 2 by 0 plus 4, which is 0 plus 4, which is 4. So that would mean the y, f of 0 means the function value at 0, which is your y coordinate, when x is 0, and that would mean that y equals 4 would be the y-intercept. So if you take y is 4 and x is 2, and you draw a graph. All right, so the next example, same thing, except that the x is not labeled for you this time. So you can actually use the x and y intercepts to help you figure out how to label your graph. So the x-intercept is let y be 0. So you're going to say 0 equals negative 0.03 x plus 60, which is going to give you negative 60. You're going to divide out the negative 0.03, and that's going to give you $2,000. Negative 2,000. 2,000, yes, sorry, there's negative over negative, it's positive. And then the y-intercept, you let x be 0. And you would have y equals, because y is the same as f of x, so you can say f of 0 or y, it doesn't matter. negative 0.03 times 0 plus 60, which is just going to be 0 plus 60, which is going to be 60. So if we look at the x-axis, we have to get up to 2,000 to be able to graph 2,000. So it's not going to make sense to label it in units of 1 or 2 or something like that. It's going to have to be fairly high. And probably 500. If we did label 500, and then 1,000, and then 1,500, and then 2,000. And then obviously on the other side would be negative 500 and so on. And then the y only goes to 60, so we could probably do every 2 blocks would be 20 here. 20, 40, 60, 80, negative 20, negative 40, and so on. So then we would plot our y-intercept is 60, our x-intercept is 2,000, and there's our graph. Okay, so another method that you can use to graph a function is to use your rate of change and the vertical intercept. So you would basically figure out your vertical intercept the same way we did it earlier, and then take the rate of change, which we've noticed is always in front of the independent variable, and then you would plot your vertical intercept and use your rate of change to help you plot some more points and then connect the points when you're done. So let's take a look at the first example using that method. So the first thing you have to do is identify your rate of change, which this is the form of the dependent variable equals rate of change times independent variable plus your initial value. So in this case here, your rate of change would be 2. But if it's a whole number, you will want to write that as a fraction just to help you figure out how high to go up and how much to go vertically and horizontally. The vertical intercept in this case is going to be, we've got y equals 2 positive 2x minus 5. So if we let x be 0, that's going to give you negative 5. Now, you probably don't have to do all those calculations all the time. You can probably do a lot of that in your head, but you should show your work if it's a test so that you can get part marks in case you make a mistake somewhere. So this one here, you plot your y-intercept of negative 5. So 0, negative 5 is on the y-axis. And then you would use your rate of change, which is your change in your dependent variable over the change in the independent variable. So if we're going up 2 units, so that would be up 2, and then we'd move to the right 1. Up 2, and then to the right 1. Up 2, and to the right 1. So that would give us a vertical change of 2 and a horizontal change of 1. And there's your graph. Now, if you wanted to, you could go down 2. That's a negative direction, but you'd have to match it with left 1 because a negative direction over a negative direction would result in a positive fraction or rate of change. Next example, if you identify the rate of change would be negative 3 over 4, and the vertical intercept would be 2. I'm just kind of skipping the steps there, sorry. So this would be, if you do the steps, go back and show you the steps. You'd have y equals negative 3/4 x plus 2. I just change the f of x notation to y notation with just y. So the vertical intercept would be y equals negative 3/4 of 0 plus 2. And that term is always going to be 0 plus 2, which is going to be 2. So that's how I got the y equals 2. So when we plot that y of 2, then we use our rate of change of, this case it's a negative rate of change, which you can write as negative 3 over positive 4, or 3 over negative 4. That negative could go in either the top or bottom of that fraction. So if we go up 3 to show the vertical change, 1, 2, 3, we would have to match it with left 4. 1, 2, 3, 4. If we'd started at our point, our y-intercept, and gone down 3, that's a negative 3, 1, 2, 3, we would have to match it with a positive direction to the right of 1, 2, 3, 4 to show the horizontal change. And then we just connect those points. My lines aren't getting any straighter, are they? Okay, so this next example that we're going to try has linear functions graphed, and you have to determine the rate of change in the vertical intercept from the graph. So the rate of change can be found using any two nice points on the graph. So for the first one, we'll just use our intercepts. And if you look at going from this intercept to the other intercept, you have a change in distance of 8 meters over a change in time of 4 minutes. But if you look at the direction of that line, it is going down or falling as time goes on, so that should be a negative rate of change. So this would be negative 2 meters per minute. And all the negative means, again, is that the distance is decreasing as time goes on. And the vertical intercept would equal 8. Y equals 8, or D I should use, because it's distance. D equals 8. So the second graph has a rate. If you just use any two nice points, I'll use this one here and this one here. So if you look at kind of the path, I'm going to draw a triangle path there, the vertical and the horizontal, you get a change from 6, start off at a height of 6, up to a height of 12, so that's a change of 6 meters. Meters, not minutes. And the change in time would be from 0 to 2 minutes. And this would be a positive rate of change because it's increasing as time goes on, so that reduces to 3 meters per minute. And then the vertical intercept would be, just look at the graph, it's crossing over the y-axis or distance axis at 6 meters. So that would be distance equals 6. The next graph, the rate, just pick again the intercepts and look at it. You've got 8 meters covered in 16 minutes. But again, if you look at the direction of the line, it's going down as time goes on, so that would be a negative rate of change. And if we reduce that, that's negative a half. 8 goes into 8 once, 8 goes into 16 twice, so negative a half, 0.5 or a half meters per minute. And the vertical intercept would be D equals 8 again. It's crossing over the d-axis at 8. And the last one, the rate, would be, if you just pick two nice points, I'm just going to pick these two right here. you've got, basically go up 1, so that's 1 meter, over, this way you've gone, you look at the scale on the x-axis of 1 block, but it actually represents 4 minutes. So that's 4 minutes, and this would be a positive rate of change because the distance is increasing as time goes on. So that would be 1/4 meters per minute, or 0.25 if you want to write it as a decimal. Just barely squeeze that in there. Oh, that wasn't very good. Okay. And the vertical intercept would be, just going to abbreviate it as V intercept, and that would be D equals 2 in this case. So it's just some practice identifying the vertical intercept and the rate of change. So we move down to the next example. We have Holy Hand of Mary High School is trying to determine the potential profits from yearbook sales, and the graph shows the projected profit made from their sales. Explain what the vertical intercept A represents. So in this case, the vertical axis is showing profit, the horizontal axis is showing sales. So if we were to explain what the vertical intercept A represents, A has coordinates 0, -200. So if you think about that in terms of this situation, it probably means that if they don't sell any yearbooks, because 0 represents their sales, so if they don't sell any yearbooks, they're going to be out $200, a -200 profit, which means they'll have a loss of $200. So if no sales implies a loss of $200. So they wouldn't make a profit. The next question asks you to explain what the horizontal intercept B represents. And B, if you look at the coordinates of B, B is 40 for sales and 0 for profit. So if we kind of think about that for a minute, that probably means that if they sell 40 yearbooks, they will make no profit, but they won't owe anything. So basically that will mean that they will break even. Okay, so they need to sell 40 books. To sell 40 yearbooks to break even or to pay their expenses or whatever. Okay, explain what C represents, and C has coordinates. If we look at the coordinates, C has a sales coordinate of 200. Go down just to make sure I'm reading that right, 200, yep. And it has a profit coordinate of 800. So that means that if they sell 200 books, if they sell 200 yearbooks, 200 yearbooks sold means a profit of $800. And the rate of change for this particular relationship, you can again pick any two nice points. So we pick point B and C, or even B and this one here. It's a little bit shorter distance to work out. So we've got the change in the vertical coordinates would be 200. Dollars, and the change in the horizontal coordinates would be from point B to the next point there would be 20 sales, and that would be a positive rate of change because the line is increasing as the or the profit is increasing as time or sales increase. So basically, as you're going to the right, the line is rising, it's going to be a positive rate of change. So this would mean $10 per sale, or per yearbook, I guess would be more appropriate. Because a sale is selling a yearbook. So they make a profit of $10 in each sale. And identify the domain and range. So in this case here, our domain, be careful, because you can't have half yearbooks or sales of halves or quarters or anything like that. So your domain would be, the sales would have to be bigger than or equal to 0, but would have to be a whole number. Or you can just say S is a whole number, I guess would be simple enough. You don't need to say bigger than or equals 0 as a whole, because that it will be a whole number. So you can just say S is a whole number. And the range, we want to put that in set notation, just to practice set notation, would be S such that S is a whole number. And the range would be anything from -200 on, so we'll just say, and this is kind of hard to write these range values when you don't really have the equation, haven't learned how to create the equation yet to figure out the dependent values, but we'll just, for now, we'll just say that the range values would be profit would have to be greater than or equal to -200, and again the profit would be an integer. And in this case, negatives are okay, because you can have negative profit means you've lost money, because you do have to pay expenses. So if you don't make enough sales to pay your expenses, you will have a negative profit, or you will owe money. And it's still integers though, because looks like the yearbooks are whole, like dollar values, no cents involved. Okay, so there's some questions there on page 319 to 321 now that you can try to practice this section.